I'm Ethan.
And I'm Emily. And we're here to help you improve your soccer game.
Here are some physics-related tips to help you succeed.
Passing the ball. Force equals mass times acceleration, so in order to pass the ball further and/or higher, one must kick the ball with more force. To accomplish this, one must lock the ankle and follow the pass-through with your kicking leg. The more force you exert while kicking a ball, the further it goes. The force you exert on the ball when you kick it is equal to the force that the ball exerts on your foot. This is due to Newton's third law. The harder you kick the ball, the more you should prepare your foot for a harder impact. When passing, the momentum of the swing of your foot carries through to the ball on impact. Therefore, the more momentum, the further the ball goes. In addition, the angle of the kick will help to determine how far the ball goes, as shown in this diagram. When receiving the ball, you want to cushion it, therefore creating more impact time and less force exerted on your foot. This will provide a player with a soft first touch after receiving a pass, and will set up the next pass that a player will make. Shooting the ball. Lean over the ball to keep the ball from rising high. The momentum of your kick will carry the ball more forwards than upwards. In this video, you can see how Ethan leans over the ball when he kicks it, and it therefore doesn't go as high. Lean backwards to kick the ball far and high. The angle of your foot and the momentum of your kick will carry the ball more upwards and further. Run faster in the build-up to the shot. This will help to increase the acceleration of the ball. When a player wants to curve a ball, they either kick the ball on the left or the right side, depending on how they want the ball to curve. Due to the conflicting directions of the airflow and the spin of the ball, one side of the ball will have lower pressure than the other. This will cause the ball to spin towards the side with lower pressure. A soccer ball is an example of projectile motion. A projectile is only affected by one force, which is gravity, as shown in this diagram.
Heading the ball. At contact, push the ball with the direction and force that you want it to go. This will create the force needed to send the ball in the correct direction and for further distances. Keep in mind that impulse equals force times time. So since the forehead is the thickest part of the skull, aim to have that be the impact point. Because the ball exerts a significant amount of force onto the head, this can help to prevent concussion and generate maximum control and power. When heading the ball, exerting more force will allow a player to head the ball further and/or with greater power. Throw-ins. A ball travels the farthest when it is thrown at about a 30-degree angle and with a slight backspin. This backspin can be accomplished by drawing the hands slightly under the ball just before throwing. Quick throw-ins can increase the chances of your team scoring or retaining possession of the ball. This can be accomplished by throwing at a more rapid rate. The forces that affect the ball after it leaves your hands are gravity and air resistance. Gravity provides a constant downward force of about 10 meters per second. Air resistance varies based on the wind speed and direction.
Juggling. If you are a beginner, you might want to deflate your ball a little bit. This will increase impact time, therefore decreasing the force, and make it easier to control. Since smaller kicks are easier to control and better for learning how to alternate feet, try not to let the ball go up past your waist. Try to kick the ball with your laces, with your foot angled slightly upward.
Thank you for watching.
We hope this video was informative and helpful.